move on and talk about connected sum. Connected sum. The connected sum of two topological spaces x and y is given by this x hash y, and this is obtained by removing a small disk from each other. In fact, instead of a small disk, you can also think of it as a small triangle as well, because a disk and a triangle, they're homomorphic to each other, and this, if this disk is solid, the triangle also has to be solid, otherwise it won't work. So let me write triangle as well, triangle from each other, and connecting the resulting holes, connecting the resulting holes with a cylinder. So this is how it would look like. Let's say this is a torus. We want to have the connected sum of this with another torus. Then what I can do, I can remove a small disk from here, remove a small disk from here, and connect them with the cylinder, right? So if I do that, the resulting figure would look something like this. This is one torus, this is another torus, and this is our cylinder that connects them. Okay, and this idea actually helps us to compute the topological invariance, let's say Euler characteristic, of a complicated surface by using the results known to us from the simpler surfaces, and we'll see how to do that. Okay, so let me give an example of this connected sum first. So this is an example. If I have a two sphere and I want to have the connected sum of the two sphere with some arbitrary topological space x, then this would just give me x. How? Well, intuitively, let's say this is our S2 and this is some arbitrary topological space. Then if I remove a disk from here and a disk from here and connect them with my cylinder, it would look something like this. Right? But now since this is a topological space, I can again deform it and it would eventually become x. This is an intuitive way to understand it. Similarly, from this figure over here, you can see that I have a 2 torus and another 2 torus. If I take their connected sum, I get a space that has 2 holes, and we denote it with sigma 2. Okay, and now let's come to the computation of Euler characteristics of these connected spaces. So if x and y are arbitrary surfaces, then chi of x connected sum of y is given by chi of x connected sum of y is equals to chi of x chi of y minus 2. Now this result might seem a bit weird, but let me try to give you a simple justification. That should help you understand that this is indeed the case. So the thing we want to do first is that instead of disks, we want to consider triangular cylinders. So that means instead of taking out disks like this from the topological space, we will take out triangles like this. And by triangular cylinder, I mean a prism that looks like this. Okay, so let's try to sketch a proof.